Hi, my name is Gaurav Bishnoi. This presentation is about object-oriented programming with Python. I'm already assuming that you have the knowledge of object-oriented analysis and design because we are going to use the concepts of this field uh, with Python. Here, I'm going to introduce you to some of the methods of Python to realize the following concepts of object-oriented programming, such as class definition, inheritance, multiple inheritance, accessibility, polymorphism, and encapsulation. Then we'll compare Python's methods with other programming languages. So, advantages of object-oriented programming. Uh, Object-oriented programming has very specific advantages, and after 80s there was a lot of encouragement for this field. So OOP provides a clear modular structure for programs, which makes it good for defining abstract data types where implementation details are hidden and the unit has a clearly defined interface. OOPS makes it easy to maintain and modify existing code, as new objects can be created with small differences to existing ones. So for large projects, that is a very useful property. OOP provides a good framework for code libraries where supplied software components can be easily adapted and modified by the programmer. This is particularly useful for developing graphical user interfaces. So Python is an interpreted object-oriented high-level programming language with dynamic semantics. It is high-level built in data structures. It has a large and comprehensive standard library. That is a very useful property, and it has simple and easy to learn syntax that emphasizes readability. That is the most popular property of Python. It has the simplest syntax of any programming language that you can find. It features a fully dynamic type system and automatic memory management. Advantages of Python are: it is simple and easy to study, free and open source, portability and expansibility, large and comprehensive standard libraries, canonical code, and it's a high-level programming language. So here's an example of class constructed or defined in Python. Class, because in object-oriented programming the basic building block is object, and object is an instance of class. So class is very important in object-oriented programming. So in Python we define the class as, here the name of the class is person, class person, and as you can observe the syntax, there is no curly brackets, it is just indentation. So there is a constructor function after the class definition, and then on the method and destructor function or method, and then object definition. I am instantiating the object named Gaurav of type class person, and I'm giving it a name using constructor function, which we will come to later. So class and object syntax, how do we define, in what manner? So it is simple, like class, subclass, in bracket superclass. We will come to those terms later. And then there are attributes and methods. As I stated earlier, it doesn't use any curly brackets, so it is just to differentiate attributes and methods from the definition of class, just to make it clear. And then object instantiation syntax: object equal to class bracket. We saw those in last slide, Gaurav, person, and the name. And similarly the syntax for method and attribute invoke are object dot attribute and object.method brackets. So here comes the constructor function or method. This method runs as soon as an object of a class is instantiated. Its aim is to initialize the object. So as we have seen earlier, I define a class named person, for example. Now I define a constructor function. The format is _init _, and in the bracket I define the parameters that will be taken by the add constructor function and will be assigned to that class. So here I am using the constructor function in this particular example to giving a name to the object instantiated by the person class. So the Gaurav is the object, okay, and it's of type person. And when I enter the name Gaurav Vishnavi, the constructor function takes it as an parameter and assigns that to the name attribute of person class, and I have attached that with the Gaurav object definition. So Gaurav object gets Gaurav Vishnavi name. So but have you noticed the self that we use in the class? Self is equal to this in C++ or Java. So whenever I am using class, if I have to refer that class, inside that class I use this. It replaces that class. So here in class person I am using self.name equals to name. So I'm assigning the parameter given to constructor function to the class person by using self. I can also use self anywhere in the class person in any different method, not constrained to just constructor function or method. So inheritance is another major property of object-oriented programming. In object-oriented programming, inheritance enables new objects to take on the properties of existing objects. A class that is used as the basic for inheritance is called a superclass or base class. A class that inherits from a superclass is called a subclass or derived class. So here the class man, and then under bracket this is called person. So man is inheriting from person class. So the superclass is person, the subclass is man. I have defined the method walk in person class, and I have defined the method run in man class. But man is inheriting from person class, so man has both the methods walk and run. After that I instantiate an object named Hulk of type man. So Hulk is a object of class man. So when I call the method walk to Hulk, it will work. Although I haven't defined that method in the definition of man, but man is inheriting from person, and person has the definition of that method. So walk, what the walk does is it prints I am walking, and as you can see on the output console, it is running. After that, when I use Hulk.run, as run is already defined under man, so there is no surprise, we get the expected output. And Python also supports multiple inheritance, but in limited form. Multiple inheritance is when we inherit from multiple superclasses in a subclass, single subclass. So for example, as you can see, this class subclass, it is inheriting from 3 superclasses. So whenever I try to invoke a method by an object which is an instance of subclass, first it will be checked in definition of subclass. If it's found, it will get run from there. If not, then the search will be in superclass 1 because it is the leftmost in the definition of subclass. And if it's not there, then the look will be then the search will be in superclass 2 and so on. So here is an example to make it more clear. Suppose the class runner inherits from person and athlete classes. So here person and athlete are both superclasses and runner is the subclass. I have defined method A in the person superclass and method A and B in athlete superclass and C in runner subclass. So as you can observe, method A is both in person and athlete. Now observe the definition of class runner, that is our subclass. Person is in the left and athlete is in the right. That means person has priority over athlete superclass. So I am instantiating runners class using a Hulk object named Hulk. Then I invoke method A using Hulk. So first what will happen is the A method will get searched in definition of runner. Runner doesn't have it, but since it is inherited from two superclasses, person is in the leftmost, so person will be get searched. Yes, person has it. Then that particular method will be invoked. So it doesn't matter whether athlete has that method or not. If person has that and it's in the leftmost place, the method in the definition of person class will be invoked. Then I call the method B from Hulk object. Runner doesn't have it, person doesn't have it, athlete has it. So the method B defined in athlete will be invoked. And in the case of C, as the runner already has that method, that particular method defined in runner will be invoked irrespective of whether person and athlete superclasses have that or not. So another very basic and important property of object-oriented programming is encapsulation or accessibility. So unlike Java or some other object-oriented languages, Python doesn't have special keywords for encapsulation such as private, protected and public. Public means the data can be accessed from anyone outside the class. Private restricts it to class itself. In Python, all attributes and methods are therefore defaultly public. But there is a procedure in Python to define private. You add double underscore in front of the variable or function name, and then that hides it from the access of anyone outside that class. Here is how we do that. Suppose I define a class course, okay, and then there's a constructor function where I have two attributes, show and hide. I made show public and I made hide private by using double underscore in front of that name. And there is also another function, show details. We'll talk about that later. So, and then I have instantiated the class using OOAD object. So when I will try to access show attribute using OOAD, I will get a response. But if I use OOAD dot underscore double underscore hide, the call will be failed because it's private and I can't access it directly from outside of the class. So here I have used another function inside the class, show details, and that uses both show and hide publicly. So if I call show details method using OOAD, I can access both attributes, show and hide. So here we are encapsulating the data. We can access the data indirectly but can't directly. The attribute which we have defined private, here it is hide. But in reality what we are doing is we are not actually or completely hiding it from the outside class. We are changing the name of the attribute that we have tried to make private by changing its name. So what the accessibility method does, it changes the private name like double underscore variable or double underscore function to underscore class name. Class name is the name of class under which the attribute or function is defined, double underscore variable. So as the name is changed, so when we try to call those attributes or methods by that name, the call gets failed because the name is not correct as it hasn't changed. So but we can use the special syntax to access that private data or methods. So here is how we do that. The name gets changed to underscore class name double underscore variable name as we have studied in the last slide. So here the class is defined as the name is course and the constructor functions similarly show and hide is private. So what I do is if I call the hide using the object name OAD dot underscore course, which is the class name, then double underscore hide, I will get a response. So I can access that data directly, which is private but in some another form. So we have achieved encapsulation but in a limited manner, not completely. So in Python versus Java, in terms of accessibility or encapsulation, Java is a static and strong type definition language, while Python is a dynamic and weak type definition language. So Java has special keywords for encapsulation, as we have discussed earlier, private, public and protected, while Python has all the attributes and methods as public in default. So Python has to use accessibility methods to realize encapsulation virtually because we can't hide them completely. It changes the name, but we can access that private attribute or method from outside by using that changed name. And next comes another important feature of object-oriented programming, polymorphism. So polymorphism is the ability to present the same interface for differing underlying forms. For example, integers and floats are implicitly polymorphic since you can add, multiply, subtract or divide irrespective of the fact that the types are different. Float is different from integer, but you can apply the same operators such as add, subtract on both of them. So here I am using the same operator on different types. So and here also we can realize polymorphism in Python just like in Java or many another object-oriented languages. And because Python is a dynamic programming language, it means Python is strongly typed as an interpreter keeps track of all variable types. It reflects the polymorphism character in Python. In Python, many operators have the property of polymorphism, such as this addition operator, and we have discussed that like floats, and in another context like the example you can see as the constant can use that operator, variables can also use that, and as with floats and integers, even strings can use that operator. So different types are using the same function, the same interface. So here I am achieving polymorphism in Python in general. So and these functions, these properties are present everywhere in Python. So there is a lot of polymorphism in Python, but there is another which we tried, although it is just polymorphism, but we try to differentiate it because we can see it more clearly, or we can observe it more clearly. So traditionally we consider polymorphism in terms of classes and objects that we define or instantiate ourselves. So polymorphic behavior allows you to specify common methods in an abstract level and implement them in particular instances. And Python supports it. Here is it how. So there is a super class person, and both millionaire and grad student classes inherit that class. So I have defined the method pay bill under the person class and in both millionaire and grad student, but whenever I try to invoke the pay bill method by millionaire and grad student, I will get different responses. So they are both of same type, but they give me different response for a same method. So here I have achieved polymorphism. So yeah, here the responses, like if I call millionaire dot pay underscore bill brackets, I will get here you go, keep the change. If I use grad student dot pay underscore bill in brackets, I will get can I owe you $10 or do the dishes. So same types of classes of type person, and so I will use that on objects. Objects instantiated on this class. I will not use the name directly, millionaire or grad student. Assume that the objects defined on these classes have the name. So I'm using same method on same type of objects, but I'm getting different response. That is polymorphism. So in conclusion, Python has some special advantages as an object-oriented programming language, but it also has some disadvantages. Python can support operator overloading and multiple inheritance that some OOP languages such as Java don't. But to clearly specify, Java specifically doesn't allow you to do that. It has been designed to not let the user to do that. The advantages for Python to use design pattern is that it supports dynamic type binding. In other words, an object is rarely only one instance of a class, so it can be dynamically changed at runtime. We can't do it in Java, it is already a compiled language. And but in terms of limitation or disadvantage, like we don't achieve the encapsulation totally in Python. We have to use some accessibility methods, and they are not totally bulletproof, but we can achieve that to some extent or virtually. So here it is. Thank you.